if people are not here, they could always look at the recording. So in order for you to schedule online math tutoring, you have to go to this place where it says ilearn.laccd.edu/enroll /AX7XNL. And here are the tutor that they have available. So for the tutor, if you actually go to this link, it will tell you which math do they tutor. Because not all of them are gonna be tutoring math 227. So you do kind of want to look at that because you don't want to go to a tutor that doesn't tutor statistics because usually it won't work out very well for you. For the recommendation, I would recommend you to try to get Juderay, which is that person right there. And the reason why I'm recommending it because I know he tutors statistics, but also he was one of my former students, and he got an A in the course. So if you need pointers on like what type of question I'd like to ask on the test, or how to use the TI 83 or 84, which we're gonna start using today, I would definitely go with Juderay. But just click right here and just enroll in the course, and that way you can schedule tutoring with people from the lab, with the math lab tutoring. Any question in regard to that? All right, so no question. Also, one thing that you kind of want to keep in mind, you do kind of want to keep on track of everything that's due. So we have our first quiz on Tuesday. So if you ever want to see if anything's popping up, just go to view course calendar. And it should tell you like what have already occurred and what's coming up. So if you look for tomorrow you have your second quiz, which will cover pretty much everything or anything that we covered today. So tomorrow quiz, it's gonna be open from 7 a.m. all the way to 7 p.m. And it'll cover pretty much a material that we covered today. And for the quiz will cover 6 questions. And one of the questions you will need to upload a picture. So you do kind of want to know how to upload a picture. If you had trouble with it last quiz, you do kind of want to perfect that before you do this quiz number 2. So just know anytime you want to see what's coming up, just go to the calendar so that way you can see if there's any quiz or any homework or any tests popping up. All right, any question in regard to the calendar? Sweet. All right, so if there's no further question, what we're gonna go ahead and do, we're gonna go ahead and just get started with chapter 2 or finish up chapter 2. The quiz should have 6 questions. It's not multiple choice, essentially, yes, you enter the numerical value. So you just have to, yes, the quiz is tomorrow from 7 a.m. to 7 p.m. And once you start the quiz, you have 15 minutes. So yeah, it's not gonna be multiple choice. Some of them you have to just type in whatever the numerical value. So say, no. So if you remember for quiz cover what the material that we went over the previous day. So since you're having a quiz on Thursday, the quiz is only going to cover what you learned from the previous day, which will be Wednesday. So the quiz is only going to cover what we go over today. Cool, perfect. All right, so let me go ahead and start sharing the notes so that way we can continue on with chapter 2 and go on to chapter 3. So if you remember for chapter 2, we left off doing a stem and leaf plot. So we're going to continue on with a stem and leaf plot. So the only thing different for this one, we're going to do a double stem and leaf plot because we kind of want to compare one population to another population. So right now we're gonna work on a double stem and leaf plot. Cool. And usually you want to use a double stem and leaf plot when you want to compare two different populations. So if you have two different populations that you want to compare, you use a double stem and leaf plot. But if you only have one data set, technically you only want to use a stem and leaf plot because you just want to use the one for one data set. But in this case, we're gonna have two data sets that we want to compare. So let's go ahead and start this. All right. So we're gonna go ahead and do this problem. So it says in this stem and leaf plot, we're going to compare Peyton Manning touchdown versus Tom Brady touchdown using the data below. All right, so if you look right here, this is your season. So it is telling us like in that one season, how many touchdowns did Peyton Manning or Tom Brady throw? So right now we're gonna kind of focus on Peyton Manning. So for Peyton Manning, what's the lowest amount of touchdown that he threw? And if you want, you can either shout it out or you can just put it in the chat. Cool. All right, so we got 9. Sorry about that. So we'll say minimum was 9. All right, what about the max? What's the highest amount of touchdown that Peyton Manning threw in one season?
49.
Almost close. It was 55. Yeah, anytime you're looking at these numbers, you try to like double check it for that way you make sure you get the right number. All right, so the minimum is 9, the max is 55. Everybody good with that? Cool. All right, so if you remember, when we do the stem and leaf plot, we essentially go from the lowest to the highest. And anytime you have a 1 digit, my recommendation for a 1 digit, always put a 0 in front of it. So instead of putting 9, I'm gonna put 0, 9. Okay, if you kind of remember, we just ignored these and we use these to do the stem. So So we go 0, 1, 2, 3, 4, and 5. All right, give me a minute. Is stop sharing. So let me just stop sharing and reshare again. Cool. All right, so stop sharing like after I follow the line. So those are all the line. And if you look at my stem, we start off at 0 because the lowest number we have is 9. So technically in the 10th place, there's a 0 in the 10th place. So that way you put 0. And if you look at the stem, the highest stem that we got is 5 because of the highest number that was, which was 59. All right. Everybody good so far how I set up the stem portion? All right, so for this one, we're gonna do the leaf. Here, give me a minute, I have a question. Oh, no question, yes, yeah. All right, so now we're gonna do the leaf portion. So for the leaf portion, we can't yet put leaf because we wanna put the leaf for whichever player. So on the left-hand side, we're gonna put Peyton. And we'll say this is Peyton leaf. And then we'll say this is, oops, Brady leaf. So on the left-hand side, we're gonna put the data set for Peyton Manning. For the right-hand side, we're gonna put the data set for Brady. All right. Any questions so far? I set up the left side to be Peyton, the right side to be Brady. All right, perfect. All right, so up next, we're gonna go ahead and we're gonna get started. So I'm gonna start off with Peyton Manning. So right now, I want any number that is a single digit. So if you look at it, we only have one number that's a single digit, which is the 9. So the 9, let's use a different color for that way you could visualize it better. You put 9 right there. So that's the only single digit that I have. So we only put that 1 9 there. Up next, we're gonna look to see if we have any number in the 10s. So we want 10, 11, 12, 13, all the way through 19. Do we have any number from 10 to 19? So right now we're only focusing on Peyton Manning. So even though Tom Brady does have a number, which is 18, we're not going to include that because right now we're just purely focusing on Peyton Manning. So for right now, where you put, there's no number in 10 through 19. So now we're going to focus on 2. So do we have any number in the 20s? The answer should be yes. We have these 2, these 3, this one, and that's about it. So if you want, you could put them in order, or if you want, you could put them the way that you get them. It doesn't really matter. So we'll say 26, 26, 26, 27, 29, 28, 27. All right, and that's it. So if you look at it, it's not in order because, well, 7 doesn't go after 8, but whatever, it's still good. So now we're gonna focus on all the numbers in the 30s. So we'll do a different color for that one. So all the numbers in the 30 will be 33, 31, 31, 33, 33, 37, and 39. So for those, we put 3, 1, 1, 3, 3, 7, 9. All right, and those are all of the numbers in the 30s. Now we're gonna do the 40. So if you look at the 40 is pretty easy because there's only one number in the 40, which is 49. So that means you put 9 right here. And lastly, we have 55. So you put 5 right there. And we're done. So that's our stem and leaf plot for Peyton Manning and how many touchdowns he threw per season. All right, any question in regard to the Peyton Manning leaf? All right, so up next, we're gonna go ahead and we're gonna transfer the information and we're gonna do this now for Tom Brady. So for Tom Brady, we're gonna see, does he have any season where he threw a single digit touchdown? So if you look at it, no. So what we're gonna go ahead and do now, we're gonna go ahead and focus, did he ever throw anywhere from 10 to 19 touchdowns? And the answer should be yes. The only one is right here in 18. So we'll put an 8 right here. So now what we want to go ahead and do, we want to focus on any 20. So we want to focus on the season that he threw 20 touchdown or in the 20. Sorry about that. So we have 28, 20. Oops, 34. Cool. All right, so those are all of the season where he threw in the 20s. So I'm going to go ahead and write those down. So we'll say 8, 3, 8, 6, 4, 8, 5, 8, 9, 4. All right. So those are the 20s. Now we're going to go ahead and we're going to focus on the 30s. So we're going to focus on the season where he threw 30 to 39 touchdowns. So that will be all three of these two, and this one. So we'll say 6, 9, 4, 3, 8, 2. All right, and those are the 30. So now if we look at how many seasons that he threw 40 touchdowns, there's no season where he threw 40 touchdowns. Like the last season that he threw 50 touchdowns. So you put 50 as a 0. And that's it for the double stem and leaf plot. Any question in regard to the double stem and leaf plot? Yeah. And like the good thing about this double stem and leaf plot, it lets you compare and contrast. So you can kind of compare and contrast and say like, okay, Tom Brady threw more seasons where he threw somewhere between 20 to 29 touchdowns. But if you look at Peyton Manning, he had more seasons where he threw 30 to 39 touchdowns. Cool. All right, and that's it for the double stem and leaf plot. So the next one we're gonna go over, so just to kind of recap which graph we have done so far. We've done the dot plot, we've done the stem and leaf plot. So the last one we're gonna be doing is the histogram. So the histogram is probably gonna be the one that's more technical because the dot plot and the stem and leaf plot is pretty easy to do. The histogram does have a little bit more steps to them. So let's go on to the histogram. All right, so for the histogram, we're gonna get, let's see. So I had a question on how did I get this last line? So the stem is 5. And right here, this represents Peyton Manning throwing 55 touchdowns. The 0 right here represents that Tom Brady threw 50 touchdowns. So that's how I got the 550. Because in one season, Peyton Manning threw 55. So to represent 55, you put a 5 on the left-hand side of the stem of 5. And the way I got 0 is because on one season, Tom Brady threw 50 touchdowns. So that's how I got the 0 on the right-hand side. So that's how I got the 550. Cool. All right, so up next, we're gonna get into the histogram. So remember, histogram is for numerical data set or quantitative data set. So for the histogram, there's gonna be a little there's gonna be some formula to be able to calculate this. So the first formula we're gonna calculate, or we're gonna go over, it's gonna be number of classes. So number of classes just represent how many rows we should have. So this is gonna tell me the max amount of rows that I should have, but it's not always gonna be that amount. It might be a little bit shorter than that, but it should be somewhere around that. If it's not that value, it should be one less than that. So in case you're wondering what's a row, it's pretty much just this. So it's telling us if we should have 1 row, 2 row, 3 row, or 4 rows, so on and so forth. So the way that we calculate that, we take the square root of our sample size. So our sample size our sample size, and we take the square root of our sample size. So the one thing that you kind of have to understand for this one, the final answer should never be a decimal. Because if you look at this, it's not like I could have half of a row or a quarter of a row or 1/10 of a row. It's either I have the row or I don't have the row. So if we get that the number of classes should be 3.15, the final answer should be 4. So we always round it up to the next whole number. So for this one, we're not going to use the kind of the rule of thumb to say if it's 5 or higher, you round it up. As long as you have a decimal value, we're automatically always going to round it up to the next whole number. All right. Any question in regard to that? Cool. All right. so up next we're gonna go over how to calculate the class width. And for the class width, I usually use the symbol CW. So if you do see CW, that is me representing class width. All right, so the way that we're gonna calculate class, pretty much it's pretty straightforward. You get the largest data value, you subtract it by the smallest data value, and you divide it by the number of classes. So just remember the number of classes should be the whole number. So you would use 4. You wouldn't use 3.15. Cool. All right. And for the class width, just to make this easier on yourself, we're always going to round it up to the next whole number. So that way you don't have to deal with any decimal or anything like that. We're always just going to round this up to the next whole number. So example of that, if you get the class width to be 10.1, the number you should be using is 11. So for the class width and for the class number of classes, both of those you should always round it up to the next whole number. All right. Everybody go with that? All right. All right, so let's go ahead and do a problem. All right, so the first thing we're gonna do, we're gonna figure out how many classes should we use. So what I want you to do is figure out what is my sample size for this data set. So what is my N? Sweet, 32. If you actually read the problem, I tell you the sample size is 32, so there's no need to really count it. Like, just read the problem, you should see sample size is 32. So the first thing I'm gonna find our pretty much our number of classes. So that's C. So to figure out number of classes, we take square root of our sample size, which is 32. All right. So far, any question I got, C is equal to square root of 32. Perfect. All right, so let's go ahead. I'm gonna share my TI-83. All right. So if you're using the TI-84 app or something like that, what you want to do to get a square root, you want to hit the second button. So mine is bright blue. So you hit second. The way I know is in second, if you actually look at the cursor, it should be an arrow pointing up now. And then what you want to do, you want to hit the button that says X square. Cool. All right, and now I have my radical. So now we can say radical 32. Enter that, and you get the answer to be 5.7. All right, everybody good? I got 5.7 for the for my classes. All right, so let's go ahead and switch over back to my notes. Can we do that again? Yeah, sure. All right, all you have to do, so you want to hit the second button. So you hit second, which is the bright blue one in mine. And then hit it. And then what you want to do, you want to look at the button that says X square. So the X square is right above, if you see the log button, it's right above the log button. So you hit X square, and now I get the radical. Then you go 3, 2, then press the enter button. And there you go. So you get 5.65, which we rounded out to be 5.7. Yeah. So let's go ahead and let's transition back to the notes. All right. So if you look at it, we got is equal to 5.7, but remember this represents how many rows are we gonna use? So I can't have 5.7 of a row. So what we're gonna go ahead and do, we're gonna round this up to the next whole number. So we get C is equal to 6. I'm gonna box that. Just for that way you know it's important. All right. So what the 6 is telling me, the 6 is telling me pretty much how many rows should I have. So kind of think about it. We have this. So we have our class and we have our frequency. So this 6 over here telling me I should have 6 rows. So you say, here we go, 1, 2, 3, 4, 5, and 6. So that's what the 6 is telling me, is saying we should have 6 rows. Up next, we're gonna go ahead and do, we're gonna go ahead and do the class width. So for the class width, if you remember, it's the max minus the min divided by C. So we get CW is equal to the max. The max in this case, I put them in numerical order from highest to lowest. So the max should be 37. My lowest number should be 16. And lastly, divided by C, C is 6. All right. Everybody good? I got 37 minus 16 divided by 6. Perfect. All right, so I'm gonna go ahead and transition over to my TI-84. So that way you can see how I punch it in. All right, so there's 2 ways how to do that. One of the way you could do it by parts, which I recommend. So you could do 37 minus 16, and you get 21. And then what you could do, you can hit the division button, and you divide the 21 by the 6. So you get 3.5. Other way you could do that, you could use parentheses, and you could say 37 minus 16, close parenthesis, divided by 6. You get 3.5. But for this one, it's a lot more work. You have to do parentheses and stuff like that. The one thing you can't do, you can't forget about the parentheses, because if you forget about the parentheses, well, you better forget about getting the right answer, because it's not going to give you the right answer. It's going to give you something completely off. So you kind of just know what your strength is, and you just use the one that's easier for you. So we got the class width is equal to 3.5. All right. All right, there, much better. All right, so we get 3.5. So that means our final answer for our class width is what? Start with an F. There you go, 4. All right. So this should probably be the easiest part. Any question in regard to how I got the amount of classes and my class width? All right, perfect. All right, so up next, what you want to go ahead and do, you want to go ahead and look at what is my lowest value. So my lowest value in this case is which number? So 16. So we put 16 right here. All right. So once you get to 16, what you want to go ahead and do next is get the class width. So if you look at my class width is 4. So what I'm going to do in order to get the next number, I'm going to add the class width. So we're going to do plus 4. So if I do plus 4, you get 20. If I want to get the next number, once again, we do plus 4, and we get 24. Now to get the next number, you do plus 4, you do 28. Now you get the next number, you get 32. You get the next number, and you should get 36. Give me a minute, stop sharing. So let's reshare. The way I got the 16, 16 is the lowest number. 16 right there, the lowest number. So that's how I got 16. Any question on how I got any of these pink numbers? All right. So up next, the thing is we want to create a range. So we want to create a range of number. We don't want to just have 16. We want to have an interval. So what we're going to do, you essentially move up this number. So this will be 16 to 20. This one you move up to 24. So it'll be 24, well, 20 to 24, 28, 32, 36, and lastly 40. So now we have our range. So for the first class is from 16 to 20. The second class is 20 to 24. The third one is 24 to 28, so on and so forth. So far, everybody good? How I got those intervals? Cool. All right, so this is where it does matter. Because the thing is right now, if you look at my first, like if you look at it, it's 16 to 20 and then 20 to 24. So if I have 20, you kind of go like, where does it belong to? Because technically right now, it belonged to the first row and the second row. So this is where we are gonna use some brackets and parentheses. So hopefully you remember what bracket mean and what does the parenthesis mean. And for this one, the bracket always go on the left-hand side, the parentheses always go on the right-hand side. Yes, we added 4 because that was our CW. So in case you forgot what the bracket mean, it means include the number. If you have a parenthesis, don't include the number. And it's always going to be the left side or the lower half number is bracket. The right hand number are going to be parentheses. All right, so remember the bracket, you tell me I include the number. Parentheses mean we don't include the number. So say like for this first one where it says 16 to 20, this means if it's a 16, if it's 17, if it's 18, if it's 19, all of them are included in this interval, but 20 is not because 20 has a parenthesis. So for this one, how many numbers do we have that fall between 16 to 20, but not including 20? Oh, should be all of these. So if you count from all of the ones that I highlighted, how many do we have? Start with an S. Yeah, it should be 6. Oops. All right, so that's our frequency. So we got a frequency of 6. Everybody got how we got a frequency of 6? Okay, so now let's look from 20 to 24. So it go from 20 to 24, but we don't include 24. So that'll be all of these numbers. All right, give me a minute. Stop sharing again.
Excuse me, I have a question.
Yeah, what's up?
So how do you always just choose 2 classes when you're trying to look for a histogram? So you see how you always get class 1 and class 2 under the classes? That's what I understood, at least. So for example, class 1 will be 16 and class 2 will be 20, correct?
Oh, yeah, yeah. If you're calling that class 1 and class 2, then yeah, you only gonna have 2 of them because you only want the lowest and the highest amount that you have for that class.
Okay, yeah.
But you need to call that like the lower boundary and the upper boundary. But if you want to say class 1 and class 2, that's fine.
Oh, I called it like that because that's what you called it. But yeah, okay, thank you.
Okay. Let's see another. All right, yeah. So this one should be 8. 8. All right. Up next, we're gonna look for 24 to 28. So 24 to 28 are all of these. So if you look at 24 to 28, we have what, 7? And then we're gonna look from 28 to 32. Oh, that's not. That should be 8 again. And then we go 32 to 36. So that should be 1. And that should be 2. All right. And that's it for this portion of it. Any question on how we fill out this portion? All right. So the last thing we're going to do the actual histogram, because this is just how to prepare ourselves to be able to do the histogram. But now that we have everything set up for us, now we could go ahead and do the histogram. Well, it only goes to 37, but if you look at it, because if you remember our class width was 4, so if you look at this one, in order to jump to here, you have to jump 4. So if you go from 36 to the next one, if you do 36 plus 4, you get 40. Yeah, and also like I know this stop past 37, but the thing is like for a histogram, you kind of want to make the class width consistent. So you don't want to just stop it at the highest number. You keep on going until the class width says to stop. All right, so let's go ahead and actually do the histogram. So I'm kind of a little bit in need of space. All right. Yeah, and like I think there's some question about how I got 2 right here. Because if you look at it, the last 2 number or the first 2 number are 36 and 37. Both of these fall in the range of 36 all the way to 40. So that way you put 2 right here because there's 2 number. The 33 goes right here for 32 to 36. All right. So why is it not wanting to share? It'll be one of those days. All right. So for the histogram, the y-axis or the vertical axis is going to be our frequency. And for the x-axis, it's going to contain our class. So if you look at our class, it starts off at 16 and then goes to 20 and then it goes to 24, 28, 32, 36, and lastly 40. And pretty much I'm getting those numbers from here. So if you're wondering how did I get 16 all the way through 40, it's because I'm using the number that we used when I created this frequency table. All right. Any question? I got the number in the bottom. All right. And just remember, these are my frequencies. So that's 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's go ahead and do a histogram. So if you look at the first histogram, it says from 16 to 20 is the frequency of 6. So here you go, 16, but it says 16 to 20. So you make sure it goes down in 20. So that way I know from 16 to 20 is a frequency of 6. So then what you want to do from 20 to 24 is the frequency of 8. So we'll do this a different color. So we'll say from 20, you go up to frequency of 8, and then come down on 24. Then what you want to do, you want to do 24 to 28 is a frequency of 7. Let's do a different color. Cool. All right, and the third bar. If you look at it for the fourth bar from 28 to 32 is a frequency of 8. So, So that's a frequency of 8. If you look at the next one, from 32 to 36 is a frequency of 1. So we'll put 1 right there. And lastly, for 36 to 40 is a frequency of 2. And this is our histogram. And if you look at the histogram, if you see how many bars does it has 6 bars. And that's kind of going back to this number 6 over here. Okay, if you remember, we said we're gonna have 6 rows. So we have 1, 2, 3, 4, 5, 6 rows. So that's what the original thing that we calculate is telling you. It's telling you the max amount of bars that we're gonna have. It's telling you the max amount of bars we're gonna have is 6. All right, but that's how you construct a histogram. Any question in regards to how we got the histogram?
Hi, yes, sorry. For the bottom, you did it by force because that was a class W, right?
Perfect, yeah, because that's the CW or class width.
Okay, thank you.
Yeah, you're welcome. All right, so let's try doing another one. All right, so for this one, we're gonna create a histogram, and we're also gonna do a stem and leaf plot, and we're gonna kind of see like what are the subtle differences, what are the similarities that both of them have, and we're gonna see like do both of them tell us the same amount of information. So for this one, we're gonna start with the easier one. So we're gonna start with the stem and leaf plot, because the stem and leaf plot should be the easier of the two, and then we'll go ahead and do a histogram. So let's go ahead and map this out. Also, one thing you always want to kind of make sure that you do, always look at the number and see, are they already put in numerical order, or do you have to put them in numerical order? So if you look at this data set, it's already in numerical order from left to right, so there's no need to have to move it around. All right, so for my stem portion, since all of you should be expert in stem and leaf plot by now, what should I put for the lowest number for my stem? Good, 3. All right, what should be the highest number for my stem? 9, good, perfect. So we'll say this is 4, this is 5. All right, so for my stem, we're gonna start off at 3, we're gonna go all the way down to 9, perfect. All right, so let's go ahead and do this. So if you look at for the stem of 3, there's only one number, which is 34. So we're gonna change that and put 4 right here. If you look at it, we don't have any numbers in the 40s or any number in the 50s. So we're gonna skip those two numbers and go to the number in 60. So those are those 4 numbers. So we'll put 64, 66, 67, 69. Cool. Now we're gonna focus on, whoa, I did this wrong. It should be 4, 6, 7, 9. Oh well. So now we're gonna focus on the 70s. So the 70s, I think there are gonna be a bunch of scores in the 70s. So that's 1. All right, all of those are in the 70s. So if you look at it, we have 2 70s. So you put 2 0. If you look at it, you have 3 74. So you go 4 4 4. You have 1 2 3 4 5 6 6. 1 2 3 4 5 6. You have 2 78s, so 8 8, and 1 79. Is that the right column? Oh no, it wasn't the right column. Yeah, I had to change to the 6. All right, so up next we're gonna do the 80. So for the 80, we have 81, 82, 82, 83, 83, 86, 88. And lastly, we have the 90s. So we have 93, 93, 96, 97. All right, so that's my stem and leaf plot. And we're done with the stem and leaf plot. It should be nice and easy. All right, any question in regard to the stem and leaf plot? All right, so let's go and now let's do the histogram. So for the histogram, what's my sample size? Good. So you get 30. So we'll say C is equal to square root of 30. Let's do what square root of 30 is equal to. So you get 5.48, but that doesn't matter because we round it up. And we should round it up to 6. Up next, we're gonna go ahead and find CW. So for CW, you get the max, which is 97. You get the minimum, which is 34. And you divide it by the classes, so that's 6. So we go 97 minus 34 divided by 6. You get 10.5. So you get 10.5 for the class width, but remember we round this up and your final answer should be 11. So here go my classes, here go my class width. All right, so let's kind of slow down. Any question in regard to how I got the amount of classes or the class width? All right, so up next we're gonna go ahead. So the 30 come from counting these numbers. So if you count them, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you actually count them, it will give you the 30. All right. Any other question before I go on to the frequency table? Technically, yeah, you could have done 5 times 6. And so you take the square root of 30. So square root of 30 is 5.48, which you round it up, you get 6. All right, so let's do the frequency table. So right here, we'll put class. We'll put frequency. That didn't work out. All right. So if you look at it, I did my class, well, my frequency table. So if you look at it, I did 6 row because if you look at it, C is equal to 6. So yeah. All right. So for this one, what is my lowest number? Cool, 34. So we start off with 34. And now what you want to do, you want to get the class width and add the class width to that. So if I do 34 plus 11, you get 45. 45 plus 11, you get 56. 56 plus 11, 67, 78, 89. And that's pretty much it. All right. And remember, the left-hand side, get the brackets. All right. Any questions so far? I got any of my red numbers? All right. So let's go ahead and get the number to the right. So to get the number in the right, remember you can't get the last number, you switch it up. So you put 45, 56, 67, 78, 89. And if you kind of look at this one, we don't know what this final answer is. But to get that, you just do the class width. So if I do 89 plus the class width, which is 11, you get 100. And remember, all of these get parentheses. Any question in regard to my class? All right, so let's do frequency. So the reason why we get 11 is right over here. Our class width. All right, so up next we're gonna go ahead and we're gonna do frequency. So if you look at the first frequency, we wanna see how many numbers do we have from 34 to 45. Well, you only have one number, so we'll put one number. Next, you're looking for a number from 45 to 56. Yeah, you just add the CW to get that final number. So if you look at it from 45 to 56, there is no number from 45 to 56, so there's no frequency there. If you want, you could put a 0. Then you go from 56 to 67. But remember, we don't include the 67. So you only get those two. Then what you want to do, you want to do 67 to 78. Ooh, that's a lot. 9, 10, 11, 12, 13. So you get 13. Then you want to do 78 to 89. So 78 to 89 are all of those. So if you actually count that out, that's 10. Perfect. And lastly, the last one should be 4. All right. So we have our frequency table. So now we could go ahead and do our histogram. So let's go ahead and do our histogram. So if you look at our histogram, if you look at the frequency, the highest amount of frequency that we have is 13. So make sure that it could go up to 13. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now we're going to do the horizontal axis. The horizontal axis, that's where you use the classes. So you want to say 34, 45, 56, 67, 78, 89, and 100. All right, so far, any question about the layout of the histogram so far? All right, so let's go ahead and draw this. So if you look at the first one, 34 to 45 is 1. So we put 1 right there. 45 to 56 is 0, so we could skip that. 56 to 67 is 2. 67 to 78 is 13. And then 78 to 89 is 10. 12, 11, 12. 12, 11. Should be roughly somewhere there. And then lastly, 89 to 100 should be 4. Cool. And that's our histogram. All right. Any question in regard to how you constructed that histogram? Cool. All right, but if you look at the histogram, if you look at the STEM, you had a question, Adriana?
Yes. Where did you get the 13 little lines on the left side?
The way I got that because our frequency.
Okay. So that since that was the highest number, that's how high we'll go, right?
Correct, because essentially you don't want to go too high or higher than you need to. So if it goes to 13, you go up to 13, you stop there.
Okay, cool. Thank you.
Yeah, no problem. All right. So if you look at my histogram, if you look at my stem and leaf plot, they kind of look the same. Like, let me get my stem here. Let's do this. All right. If you kind of look at my stem and leaf plot, if you look at my histogram, they kind of have the same shape. Pretty much for the shape, like what type of shape does it have? Is it skewed to the left, skewed to the right, or does it kind of look symmetric? Well, if you look at it, which side have the least amount of data set, the left side or the right side? Cool. So the left side. So for this one, or so for this one, you should get that left skew. Cool. And that's it. So if you look at it, it doesn't really matter if I use a stem and leaf plot, if I use a histogram. Both of them should kind of give us the same result, that our data set is skewed to the left. So it's just like different way of doing the same thing. Like the good thing about a stem and leaf plot, that you can actually see how many, or like the numerical value. Because if you look at the histogram, you just know between 78 to 89, but you don't know what are those number between 78 to 89. Versus if you look at the stem and leaf plot, like I could tell you that this 4 represent 34. So you could directly see that value. All right, but that's it in regard to a histogram versus a stem and leaf plot. Any question? Yeah, and I did see the question about, are we gonna have to do all of these stuff on the quiz? Like, if I ask you to do a histogram, this is the way I want you to do the histogram. But like for the quiz, I have my way of, like, I'm not gonna ask you, each question will ask you something different. Like I'll ask, one of the question will ask you, what are the classes? What are the class with? Other question will ask you to do the table and stuff like that. So shouldn't be that bad. All right. But any question in regard to this before I move on? Okay, all right. All right. So this last one is kind of just going over how can we misrepresent our data set. So I want to show you different way that we can misrepresent our data set. So if you look at this first one, it says vertical axis. So it's saying inconsistent vertical scaling. So if you kind of look like when I was doing my frequency, I will always go up by 1 or go up by 2 or however much I want to go up by. But inconsistent vertical scaling will be, say we start off at 1 and then we go 3 and then we jump to 10. Like it's not consistent because it's not going up by a consistent number. We're not going up by 1, then 3. So the next natural number should be 5, then 7. So that what I mean by inconsistent scaling. All right, incorrect vertical scaling is essentially the same thing. And vertical axis doesn't that doesn't start at 0. So anytime we're doing a graph, you always want it to make it start off at 0. Because if I look at these two graphs, are both of the graphs telling me the same thing, or are they kind of telling me something different? So let's say this is graph A. and this is graph B. Which one is showing that there's a big difference between Democrat, Republican, and Independent? All right, so far we have 2 Bs, 3 Bs, 1A, cool. All right, so you should have chose that B is showing there's a big difference, because if you kind of look at this compared to the next highest one, it's showing there's a big difference. But is there actually that big of a difference? Not really, because from 62% to 54% is a difference of 8%. But the way they make it seem, they're making it seem like it's a difference of like, it should be like 5 times that number. So whatever 62% is, Republicans should be somewhere like at 10%. So the reason why, if you look at where did it start off at, it doesn't start at 0. If you look at the left one, this one is starting off at 0, and that's why you always want to start off at 0, because if you don't start off at 0, it's gonna make it seem like there's a major difference when there actually is no difference. All right, so that's for the vertical scaling or vertical axis. All right. So let's go to class width. So if you notice for this class width, I put value overlap. So if you kind of remember when we're doing the histogram, we always make sure that each number corresponding to one single row. So if we had like 34 to, what was that? 34 to 45. Yeah. If we had like 40, we know exactly it should go in this row. But if you look at this one's saying 0 to 3, and this one's saying 2 to 5. So if you have a 3, it's going to go into this row, but it's also going to go into this row, which is what happens when you have values that are overlapped. So you never really want to have values that are overlapping, because if you have values that are overlapping, then they're going to be counted double. Same thing for this 2 over here. Because if you have 8, 8s are going to get counted here, but it's also going to get counted over here. All right. So that's one value overlap. There's also the case where the class width is different. Because if you kind of notice for our class width, we always use the same class width. So in the first one, the class width was, what was it, 4? And the second one, it was 11. So we always added that same portion. But if you look at this one, oh, sorry about that. So if you look at this one, the class width is 10. Same thing for this one, is 10. But if you look at this one from here, well, you can kind of clearly see it's not 10. So anytime we're doing a histogram, you always want the class width to be consistent. You don't want to be inconsistent, where you start by going 10, 10, and then you just jump and say like, okay, the next one's going to be 22. So that's the case where you could get something that's misrepresented, because like if we have a bigger class width, like we should expect this one to have a bigger frequency. And the reason why it should have a bigger frequency, yes, because it has a bigger class width. So anytime you're looking at graphs, these are kind of the things that you want to look at. You don't want to just look at the graph. You want to see like, okay, is it starting off at 0? How are they defining the class width, so that we can kind of make sure they're not overlapping and stuff like that. All right, but that's pretty much it for chapter 2. Any question in regards to chapter 2? All right, so we're gonna go on to chapter 3. So chapter 3 is where we have all the math. So if you've been waiting for all the math, this is where you're gonna get it. All right. So up in chapter 3, what we're going to be focusing on, we're going to be focusing on 3.1. We're going to be focusing on the central tendency. So the central tendency is telling us what tends to happen the most. So the way that we're going to be measuring the central tendency at the beginning, we're going to be using the mean. So the mean is going to tell us what is the central tendency. So kind of think about it. It's telling you like normally what happened. So like if I ask you if I'm cooking chicken, like how long should I cook the chicken for? So how long should I cook the chicken for? Say I'm cooking a chicken breast. Cool. So we have somebody saying 30 minutes. But is it always going to be that I cook the chicken in 30 minutes? Like sometimes it could be, it take a little bit longer than that. And it take me 32 minutes to cook the chicken. Or it might take me 28 minutes to cook the chicken. But the mean is telling us on normal how long it should take, but it's not always going to be that amount, but it should be somewhere roughly close to that value. All right. So we're going to go over some symbols. So first we're going to cover what do we already know. So what does this represent? What does little n represent? Cool. Sample size. What does capitalized N stand for? Or uppercase N stand for? All right, so population. Cool. All right. Everybody good that lowercase n is sample size, uppercase N is population size. Sweet. All right, X is our variable. Or in the other word, it's our data. So X is going to correspond to our data set. And then lastly, we have this. All right. So this symbol is literally just telling you to add. All right. So if you look at it, it's telling you add all the data and then divide it by your sample size. So that's how we're going to calculate the mean. Any question on how we calculate the mean by just adding up all the number and dividing by however many numbers we have? All right, so no question about that. All right, so if you notice there's two different symbols. We have X bar and we have mu. So this is the Greek letter, mu. So X bar corresponds to sample mean. So whenever you see X bar, this means we're calculating the mean of the sample. Mu corresponds to population mean. So if I have the entire population and I find the mean of that entire population, we say mu. If we find the mean of a sample, then that's the sample mean, and we represent that by doing X bar. So it is important that you kind of know the difference between X bar and mu, because throughout the whole semester, we're going to be using these notation for the formula. So you do kind of want to understand that anytime you see mu, that stands for the population mean. Anytime you see X bar, that stands for the sample mean, because we are going to be seeing these notation for further formula, like all the way till we get to chapter 14, we're going to still be seeing the notation. So you do kind of want to have the understanding that mu is the population mean, X bar is the sample mean. All right. Everybody good for that? All right. So here go kind of like an illustration. Yeah, the summation, that symbol, yeah, and then add up all the data. All right, so here go kind of my illustration. What the mean is pretty much the balance point. Because essentially you're gonna have number to the left of the mean and you're gonna have number to the right of the mean, but the whole goal is that the mean should be pretty close to all of the number because it should be the balancing point of all the number. So if you ever gone to the, what do you call it, to the park, if you see like a seesaw, pretty much the mean is pretty much the balancing point of that seesaw because that mean makes sure that there's the same amount of number to the left of the mean and to the right of the mean. All right. So let's go ahead and do our very first problem for the mean. All right, so for this problem, it says find the mean of the 8 randomly selected number. All right, so here go our data. So very much as our x. So for this one, is this a sample or do I have the entire population? So for this one will actually be a sample. Because kind of think about it, if I have the entire population, why do I have to do a random selection? You only do a random selection if you're collecting a sample. Because if I have the entire population, I would say these are all of the number set. But since I say I randomly selected the number, that's kind of telling you that this is a sample. So anytime you see that we did a random selection, that's my hint to you telling you this is a sample. So we should say sample. So that means we're going to be finding X bar. So to find X bar, we're going to add up all these numbers. So we'll say 15 plus 21 plus 26 plus 25 plus 21 plus 23 plus 28 plus 21. Cool. And then what you want to do, you want to divide it by however many numbers we have. So for this one, I tell you we did 8 randomly selected number. So since there are 8 randomly selected number, you divide it by 8. So we'll say 15 plus 21 plus 26 plus. All right, so you get 180 divided by 8. If you do 180 divided by 8, and you get 22.5. All right, and that's how you find the average. Any question regarding how to find that average? And yes, remember, this is the sample mean. And just remember the sample mean is the balancing point. So essentially all numbers are going to be around these numbers. Now for this one, you don't want to round it up. For this one, you just want to leave it as is. You only do the rounding up when we're doing the histogram. So only for the histogram, everything else, like you usually just use the exact number. All right, so let's go on to the next problem. All right. So for this one, it says a statistic instructor randomly selected 6 students in class and got their height. So once again, is this a sample or is this my entire population? Cool. Yeah, so they say randomly selected 6 students. If they were to tell you we selected all 6 students, that's telling you that's the population. But once again, since they're telling you they randomly selected, it's telling you the sample. So once again, we're going to get X bar is equal to 74 plus 66 plus 68 plus 69 plus 73 plus 70. All right, and for this one, what should I divide it by?
6.
Yeah, 6. So you randomly select the 6 students. So for this one, you get 420 divided by 6. 420 divided by 6 is 70 inches. Cool. So if you look at the mean, it's telling us the central tendency height for these 6 students is 70 inches. But if you kind of look at their height, not all of them have 70 inches. There's some students that are taller than 70 inches. There's some students shorter than 70 inches. But the central tendency is telling you like what tend to happen. Like most students are somewhere near 70 inches. All right, and that's it for the second problem. Oh, that's weird. Any question in regard to the second problem? All right, so let's move on down. All right, so the other way that we could calculate the central tendency is by calculating something called the median. So for the median is the middle number. So we're gonna arrange our data set from lowest to highest, and our median will always be the middle number. So whatever number is in the middle, that's gonna be our median. So there's gonna be 2 scenarios that's gonna occur depending on our sample size. So if our sample size is an odd amount of data set, pretty much you're gonna have one number in the middle. So you're only gonna have one number in the middle. But if we have an even amount of sample size, then you're gonna have 2 numbers in the middle. And the way that we find the median, we're gonna take the mean of those 2 numbers in the middle. So yes, no, if we have an odd amount of data set, there's only gonna be one number in the middle. If there's an even amount of data set, there gonna be 2 numbers in the middle. So that's how we're gonna find the median. So arrange the data set from lowest to highest, and then you find the number in the middle. And also the median, you usually use this if your data set is skewed to the left or to the right. Usually the mean, we use that for symmetrical data set. But if our data set is skewed to the left or to the right, you usually use the median. All right. So let's go ahead and do our very first problem for the median. So if you look at this data set, we have 19, 13, 15, 25, and 18. So you can't just go, hey, 15 is in the middle, that's our median. That will be completely wrong. The first thing you want to do is you want to put them in order. So you want to go from lowest to highest. So we'll put 13, we'll do 15, we'll do 18, you do 19, and then you do 25. Any question how you put them in order from lowest to highest? All right, and then what you want to do, you start crossing it out. So anytime you cross out a number to the left, cross out a number to the right. So you cross this, I crossed out 25, cross out 15, you cross out 19, and you're left with this number in the middle. So that's your median. So usually the median is just trying to divide the data set into like 50%. So 50% of the data set should be to the left, 50% of the data set should be to the right. So if you kind of look at it, it's divided where these 3 numbers are to the left of it. These 2 numbers are to the right of it. So that's what the median is trying to do, is trying to break it up where 50% goes to the left of that median and 50% goes to the right of that median. All right, but any question in regard to the median for that first example? All right, so let's do a second example. So we're gonna find the median of this one. So first thing first, you wanna arrange them from lowest to highest. There you go, 27. You go 30. You go 35. You go 38, 42, and 81. All right. Everybody go. I got 27, 30, 35, 38, 42, and 81. Okay. All right, so let's go ahead and let's start crossing them out. So cross out this, cross out this, cross out that, cross out this. So if you notice, I get two numbers in the middle. And the reason I know I'm going to get two numbers in the middle, if you look at how many numbers I have, it's a total of 6 number, which is an even number. So since it's an even number, I should have already know there are going to be two numbers in the middle. So now what we're going to do, we're going to take the mean of the two numbers. So you go 35 plus 38. And since there's two numbers in the middle, you divide it by 2. So we do 35 plus 38, that gives you 73 divided by 2. If you do 73 divided by 2, you should get 36.5. And that's your median. Cool, good job for the people who posted it up on chat. But everybody got how I got 36.5 for the median? Okay. So then if you put 36.5 right here, if you notice, now we have 3 numbers to the right of that median, but we also have 3 numbers to the right of that median. So it's breaking it up between 50%. So 50% goes to the left of it, 50% goes to the right of it. All right. Any question for this last problem? All right. So bonus question, what I want you to do, I want you to find the mean of this data set. So just find the mean of the data set. Once you find the mean of the data set, post it on chat. And let me do that too. All right, so good. So you should have gotten 42.17. So normally, if all our data sets are pretty symmetric or all of our data sets are kind of close together, our mean and our median should be pretty much the same. It's not going to be exactly 100% the same, but it should give you roughly the same number. But if you look at this one, we have kind of like a big difference. We have a difference of like 6 points. Okay, if you look at 36.5 and 42.17, there's kind of a difference. So what do you think, like, why do you think we're seeing such a big difference? Or why are we seeing such a difference? Cool, perfect. We're already using cool terms like outlier. All right. So yeah, so if you actually look at it, somebody posted on the chat because of the outlier, which pretty sure she's referring to 81. So that's the case. So the thing about the median is resistant. So the median is resistant to outlier, because if you look at how we calculate the median doesn't care about the lowest number or the highest number. It just cares about which number is in the middle. So the median is resistant to outlier. But if you look at the mean is not resistant to outlier because the mean has to take into account all the data set. And once you add up all the data set, you divide it by how many data sets you have. So the mean is not resistant to outlier. So anytime you have an outlier, you most likely want to take the median because the median will give you a more true representation of the data set. versus the mean, because the mean will either get inflated or deflated, because the outlier will either increase it or it will actually decrease it. All right, but that's it for the median. Any question in regard to the median? All right, and if you are having trouble with the median, here go a YouTube link to go to, and he'll go over other example about the median. So in case the example I did are not really working for you, check it out. All right, so up next we're gonna go over other definition called the mode. The mode is whichever number occurs the most often. So normally, if no number occur most often, we say there is no mode, because mode represent the number that occur most often. So if all number occur one time, pretty much we have no mode. But once we have a number that repeat the most, pretty much that will be our mode. So I'm already getting answer for the mode. Good. So if you look at it, our mode is whichever number occurred the most often. So if you look at 76, 76 will be our mode. And that's how you find the mode. So it should be pretty nice and easy. All you have to do is just look which number repeat the most. Whichever number repeat the most, that's the mode. For the mode, it is possible for you to have two mode, or it could be bimodal. So if I have two numbers that occurred the same amount of time, you put both of them as your mode. But if there's clear cut one number that repeat the most, you just put that one number. All right. Any question in regard to the mode? All right, so let's scroll on down. All right. So up next, we're gonna kind of get into the mean, median, and mode, but you're gonna focus on the mean and the median. So depending on our mean and our median, we could kind of be able to tell what type of distribution we're gonna get. So remember, whenever I talk about distribution, it either skewed to the left, symmetric, or skewed to the right. So depending on which is bigger, the mean or the median, I can actually tell that if it's gonna be skewed to the left, symmetric, or skewed to the right. So we're gonna go over each case scenario. So I'm gonna zoom in on it for that way you can just focus on that one. Cool. So first one we're gonna focus on is skewed to the left. So if our data set is skewed to the left, in this case, the mean should be smaller than the median. In this case, why do you think the mean will be smaller than the median? Like, why wouldn't the median be bigger than the mean? So remember, you can either put it on the chat, or if you want, you can just talk it out. Well, what about the outlier? Where are the outlier? Are the outlier to the left of it, or are the outlier to the right of it? Oh, yeah. So you're gonna have outliers over here. So these outliers are now gonna be extremely low value. Since they're gonna be extremely low value, instead of making the mean inflated, they're actually gonna deflate the mean. So that's why you get it where the mean should be smaller than the median, because if it is skewed to the left, you're gonna have values that are extremely small. So those values that are extremely small gonna make the mean smaller than the median is. All right, so that's skewed to the left. Let's go to symmetric. All right, so for symmetric data set, if you look at it, you have the same amount of pull to the left than to the right. So since you have the same amount of pull from the left side and from the right side, the mean and the median should be pretty close to themselves. So just remember, like I said before, they're not gonna be always exactly the same number, but these should be pretty close to each other. So if I get one is like 15 and the other one is 15.5, since there's not like a significant difference between the two of them, we can actually say that these data sets are symmetric because they're pretty close to each other. So that's what you get when you're symmetric, when your data set is symmetric. The mean and the median are approximately equal to each other. Lastly, we have skew to the right. So in skew to the right, we're gonna have the outlier on the right-hand side. So what that's gonna do, it's gonna make my mean and gonna inflate the mean. So instead of having a low number for the mean, it's gonna make my mean even bigger than what it should be. So that's why we're gonna get mean is greater than the median. All right. And those are our three cases. So we have our case for skew to the right, symmetric, and skew to the left. So just by knowing the mean and the median, we could kind of already tell what type of shape should we have in our distribution just by knowing the mean and the median. All right, any question in regard to that before we follow through and do a problem in regard to this? All right, let's go on to the problem. Oh. So what I want you to do, take a minute and find me the mean and the median of this data set. And once you find the mean and the median, if you want, you can put it on the chat. And I'll let you know if you got it right. Well, the 15.5, I just made it up. I was kind of showing you that the mean and the median don't have to be exactly the same. But as long as they're close to each other, that would I mean that they should be approximately equal to each other. So that's what the 15.5 represent. Is nothing that I actually calculated. It's just saying if my median is 15.5 and my mean is 15, these two are approximately equal to each other. So that's why we could say symmetric. But there's no calculation that actually there. Cool. So you should get 78.23. That's good. Perfect. And for the media, what did we get for the media? There you go. Perfect. Also, this is like, if you kind of look at this and you kind of understand what the median is, the median should be the middle. So you go like this and this row. Are you going to cancel each other out? So you can start crossing, 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 crossing. And you get those two numbers in the median. So if you're for the mean, in order to calculate the mean, you add up all the numbers and then divide it by however many numbers we have. In this case, what's our sample size? Or is this our sample size?
30.
That's 30. For this one, is this a sample or is this the population? Yeah, good. This is a population. Because for this one, it's just kind of like assuming this is the entire class. So since this is the entire class, it will be a population. So technically, the 78.23, that's our mu. All right. Everybody good on 78.23 is our mean, 76 is our median, and our sample size, well, not our sample size, our population size was 30. All right, so let's look at the mean and let's look at the median. So if I look at the mean and the median, what should I say? Should I say that they're pretty close to each other? Or is there like a big difference between the two? Ooh. Yeah, they're pretty close to each other. So let's say skew right. All right, cool. So what I'm gonna do a poll right now. So I just want you to say A if it's skewed to the left, B if it's skewed to the right, or C if it's symmetric, based off of the mean and the median that we found. All right, cool. So now we got 75. Cool. All right. So if you look at it, we got one person that said skew to the left. We got 5 people who said this was skewed to the right. And lastly, we had 16 people who said this was symmetric. So for this one, the final answer should have been, this is symmetric. Because if you look at the mean, if you look at the median, they're pretty close to each other. So they're approximately equal to each other. So for this one, we should say it is symmetric. So that's what we'll say right here. All right. And that's it for mean, median, and the mode. Any question in regard to the mean, median, and the mode? All right, so this is us just focusing on central tendency. So up next, we're gonna focus on something called variability. Because variability is telling us like how much deviation should we expect? Because if you kind of think about it, like when I asked you like how long did it take to cook a chicken, and somebody said it take 30 minutes to cook a chicken. So what the variability gonna tell me? It gonna tell me how far away from 30 minutes could it be? Like, could it be that take me 35 minutes to cook a chicken? Could it be that take me an hour to cook a chicken? Or could it be that take me 2 minutes to cook a chicken? That what the variability is telling us. It's telling us how far away from our central tendency can we go where it could still be possible. So let's scroll on down. All right, so let's go over variability. So when we talk about variability is telling us how spread out the data set is. If we have a high variability, the reason we have high variability because that means we have a big range. So it's telling us our data set is spread out a bunch. But it's also telling us how concentrated our data set is. So if we actually have low variability, we can have low variability because we have multiple numbers that are repeating. And if we have multiple numbers that are repeating constantly, that could give me a low variability, because if we have a bunch of number and not all of those number are repeating as often, that's going to give me high variability. So kind of thinking about that, like high concentration equal low variability, low concentration equal high variability, we're going to look at this histogram. And what you're going to do, we're going to do a poll again. And you're going to tell me which of the three have the lowest variability. So let me go ahead and do the poll. Select the correct one. Let's say relaunch. Continue. Cool. So tell me, of the three histogram, which one do you think have the lowest variability? So remember, lowest variability means it has a high concentration. I think it's Jeopardy. There. All right, cool. So let's see what's going on with the poll. So let me share it with you. All right, so we kind of have like a good divide between A and C. So I could tell you now, it is between A and C. So anybody who chose B, well, you're out of the running. So what you want to do is, if you look at both of the graph, which one have a higher concentration, A or B? Oh, sorry, A or C? Well, the answer for that, it should be C, because if you look at C, if you look at it from 70 to 80, you have a high concentration of students who got 70 to 80. If you look at A, pretty much all of the students pretty much are all over the place. You have students who got 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. So they're all over the place in A. But if you look at B, well, sorry, if you look at C, C is highly concentrated between 70 to 80. So that means we're getting a high concentration there. So that means this will have the lowest variability. So we'll say this will have lowest variability. So anytime you're looking at a graph, you're trying to look at it, okay, is it all over the place? Which A is all over the place. If you look at C, C is concentrated in the middle. So that's kind of telling me you have a low variability there. All right, but that's it for that. Stop share. All right. Any question why C is the lowest, had the lowest variability? And then if you look at B, B should be the second lowest variability, and then A will have the highest variability, in case you were wondering. Cool. All right, so the first way we're gonna figure out which data set have the biggest variability is we're gonna calculate something called the range. So the range is you get the highest number and you subtract it from the smallest number. So you get the maximum minus the min. So usually if you have a big range, that's telling you you have a high variability. If you have a low range, that's telling us you have a low variability. Could kind of think about it, what the lowest value your range could ever be. So what the lowest it could ever be? Good. Like the lowest it could be is 0, because say if I have a test and everybody on the test happened to get 76, well, there is no variability, because if I get the highest number and if I get the lowest number, well, the highest number and the lowest number is the same number. So you will get the range is equal to 76, because that's the highest number, and you subtract it from the lowest number, which is 76, and you get 0. So that's the lowest it could be. So if your range is ever equal to 0, that means all the numbers are the same. All right. So let's go ahead and do this data set. So I have two data sets. So what I want you to do, I want you to calculate the range for both of these data sets, and then you tell me which one have the lowest variability. So would it be data 1 or data 2? And I already put the data set from lowest to highest, so that shouldn't be that much of an issue. The range formula is you get the maximum or the highest number subtracted from the lowest number. All right, so if I get the range for data number 1, you get 93 minus 61, and you get 32. If I get the range for data number 2, you get 81 minus 61, and you get 20. All right, so which one will have the lowest variability? Data 1 or data 2? There you go. So we'll say data 2 will have the lowest. All right, so we'll say data 1, well, sorry, data 2 will have the lowest variability because a range of 20 is smaller from a range of 32. So just remember, the bigger the range is, the more variability you have. The smaller the range is, the lower the variability will be. Ideally, if there is no variability, the range will equal to 0, but most of the time that won't happen. Any question in regard to range? All right. All right, so this is the fun formula. So this is standard deviation. This is the other way to calculate variability. So same thing as range. The smaller your standard deviation is, the least, well, the lower the variability is. The higher standard deviation is, the bigger the bigger the variability will be. Cool. So if you look at it, you have two different formula because it could be either the sample standard deviation or it could be population standard deviation. So this top one is sample. All right. Cool. So if you look at S is your sample standard deviation. If you look at this one, this is the Greek letter. It's called sigma. Sigma is your population standard deviation. All right. Any question in regard to any of them? All right. So far, what we're gonna do, we're gonna go based off what we already know. What are some of the stuff that we already see here? So, what does this represent? Well, what type of mean? Sample mean. Perfect. All right. What does this mean? Oh, to add. All right. What does the n represent? Sample. Perfect. Oh, sample size. Cool. So that why it's important that you know the notation, because once you go into further formula, you're gonna start seeing those notations. So it's very important that you already kind of understand those notations. So that way when you're looking at the formula, you're not like completely lost about what it is doing. All right. Cool. So I'm gonna kind of go over this part and then we're gonna move on to an actual problem. So if you look at it, it says x minus x bar. Well, what does x mean? What did we say x mean? Perfect. No, it's not the date, but data. Perfect. All right, cool. Yeah, it's your data. So if you look at it, it said get your data subtracted from the mean. So that means we have to get every single value and subtract it from the mean. Because if you kind of think about it, we're doing the variability. We're trying to find out like how far away are each number from the mean. So that what we're doing, we're do x minus the sample mean. We're trying to figure out how far away are each one of these x value from the mean. All right, cool. All right, so the rest of it, we're just actually gonna go ahead and do a problem for that. So we're gonna do a problem for that, and that's probably gonna be it for today. Cool. So what we're gonna go ahead and do, we're gonna go ahead and do this data set. So if you look at the data set, it says population. So since it says this is the population, we're gonna use this formula. Oops. Already messing up. All right, so we're gonna go ahead and do that formula. So let's go ahead and do that formula. So remember, we're doing this formula because the problem said this is a population. So since this is a population, we have to find population standard deviation. So first thing we're gonna go ahead and do, anytime you find standard deviation, the first thing you wanna do is find mu. So to find mu, in case you've forgotten how to find the mean, you add up all the numbers and you divide by however many numbers we have. So if you look, we have 1, 2, 3, 4, 5, 6. So you want to divide by the number 6. Cool, thank you. And somebody already got 5. All right. Everybody get that the population mean is equal to 6. Oh, sorry, population mean is equal to 5. All right. So let's go ahead. So kind of like the easy way to do this, and this is the way I'm going to make you do it on the test. You want to do this chart. So you do kind of want to get used to this chart because on the test, I am going to make you fill out this chart. So when I'm finished with this chart, the chart should give me this on top. And that's the only thing it'll give me. So I still need to do some steps in order to find the standard deviation of the population, but it will give me that portion that I highlighted in yellow. So let's go ahead and do this. So where see X, X is my data. So I'm gonna put my data. So you put 3, 6, 1, 8, 7, and 5. Any question in regard to how I got that? All right. So in a test, like I'll give you this table and all you have to do is just input the number for each one of these slots. So like for this one, if you look at it, it says X minus the mean. So that means you get X, which is 3, subtracted by the mean, which is 5, and you get -2. Now go to the next one. You do 6 minus 5. 6 minus 5 is equal to 1. Go to the next one. 1 minus 5 is equal to -4. All right, go on to the next one. 8 minus 5 is 3. 7 minus 5 is 2. 5 minus 5 is equal to 0. Any questions so far? I got that middle row. or sorry, middle column. Column rows. All right, so what I want you to do right now, I want you to add up these numbers and tell me what do we get. Cool. So if you add up all those numbers, you should get a 0. Because if you kind of remember when we went over the mean, I told you the mean is the balancing point. So since it's a balancing point, it should balance the amount of negative number and positive number. So when you add them together, it should always give you 0. So that's how you know if you have the middle table correctly filled out. If you add them up, if they add up to 0, it's correct. All right, so let's go ahead and do this portion right here. So I already did x minus mu. So the only thing I have to do is take it to the second power. When you take anything to the second power, it automatically becomes positive. So all of the number here, these should all be positive. So if you get a negative number in this row, well, you should know it's wrong because there should be no negative number here. So you do -2 square, you get 4. You get 1 square is 1. You get -4 square, that's 16. You do 3 square, that's 9. You do 2 square, that's 4. You do 0 square, well, that's 0. All right. Any question for that last column? All right. So if you look at this formula, we have this symbol over here. What does that symbol symbolize again? Add. So what we have to do in order to get the summation of x minus mu squared, you add up all of the number on the last column. So you do 4 plus 1 plus 16 plus 9 plus 4 plus 0. Let's see what did I get. 4 plus 1 plus 16 plus. Cool. You get 34. So when we're doing sigma divided by square root, the top should be 34. Because that's what the summation of x minus mu square is. It gave me 34. All right. Any question where the 34 come from? All right. Which number should I put for capital N? There you go, 6. All right, so what I'm gonna go ahead and do, I'm gonna go ahead and do this in the calculator. No, don't wanna meet you all. All right, so in the calculator, we'll say second x squared, you put 34 divided by 6. Cool. And you get 2.38. So you get sigma is equal to 2.38. All right. Any question regarding how we got sigma is equal to 2.38? Cool. All right. So I'm going to show you how to do this and how to double check your answer on the calculator. So if you have a TI-83 or 84, make sure you have it out right now for that way you can kind of follow along. All right, ready, set, and go. All right, so the first thing what you want to go ahead and do, you want to hit the stats button. So if you look at the stats button, is right below the delete button and it's close to the left arrow. So you want to hit stats. So you should be in this screen where it says edit, calculate, and test. So in our problem, we want to edit the problem because we want to enter data set. So I'm going to go to edit. All right, anytime you have number in your list, so I have L1, L2, and L3, what you want to do, you want to press the up button, press clear, and press delete. And now everything is deleted. So now I can start from a new list. All you have to do now is put all the numbers. So we put 3, then press enter. Press 6, press enter. Press 1, press enter. Press 8, press enter. Press 7, press enter. Press 5, press enter. Any question on how to enter the data set? Perfect. All right, so then what you want to do, you want to go right here back to the stats button. And now what you want to do, you want to move it over to calculate. So you want to move over here where it says calculate. And you want to choose the 1 bar stats. So 1 bar stats. So in mine, it's asking me for the list. It's asking me where did I put the numbers. So I put the number into L1. So I have L1. My frequency list, you leave that blank because we don't have a frequency list. And you just go here where it says calculate. Cool. All right, so if you look right here, it gave me the sample mean, which X bar is equal to 5. If you look right here, it gave me 2 standard deviation. Because if you remember, we have 2 different standard deviation. We have sample standard deviation, but we also have population standard deviation. So if you look at the one that says SX, that's sample standard deviation. The one that says sigma X, that's population standard deviation. So for this one, you kind of have to just know, is this for a population or is this for a sample? If it's for a sample, you use, let me type it in over here. You use SX, that's for sample. And if it's for population, well, I can't really put sigma there. You use sigma for population. So if you look right here where it says sigma of X, it says 2.38. So that's the way that you could double check your answer. All right, any question in regards to that? Cool. All right, so let me transfer it over.
Professor, yeah, I do have a question. Sorry. So I miss. So you pretty much entered the data in L1, and then you press what again to display it?
Oh. All right, so you press stats. You move it over where it says calculate. So you want to use the right arrow.
Right.
So you move it to right, and then you hit 1 bar stats.
Oh, okay. All right.
And then you go to calculate. It should be good. So you get sigma of X is equal to 2.38.
Perfect. Thank you.
Any other question in regard to the TI-84?
Quick question.
Yeah.
When I did it on mine, so I hit stat, then calculate, and then 1 bar stat, and then I pressed enter, and it says error data type error. But I still got the answer. It still gave it to me.
So it still give you the list?
Yeah, so I get those answers you have on yours, but when I click enter, it says error. It says error data type error, and then I press OK, and it gives me the same answers you have, but it's just telling me there was an error.
I think I need to see it to be able to figure out what's wrong with it. Because as long as I give you the answer, that should be fine. So I could double check that later.
Okay. Thank you.
Yeah, so if you want to enter the data set again, so you go edit, oh, sorry. Yeah, so you go to stats, and then you just choose edit, and then you need to enter the numbers. And every time you enter a number, you have to press enter to go to the next number. So you want to go like 5, enter, 7, enter, 5, enter, so on and so forth. And that way you can enter all the data set. All right. Any other question in regard to calculator? All right. Great. All right, so that's it for today, class. So just remember, you have a quiz tomorrow. And the quiz is pretty much going to be on how to do a histogram. So pretty much the whole problem going to be how to do a histogram. So do not destroy any of your notes once you're done with a problem. You're going to need the answer that you got on the previous question in order for the next problem. So it's all going to be from the same data set. And you're going to be step by step by step. So like one of them will be like, what is the sample size? The other one will be, how many classes should you use? The other one should be, what's the class width? And so on and so forth. So just know each question you're going to follow through to the next question. So keep your notes for that way you could follow through with it. It could be the same thing for most of the test questions. The test question, it could be the same question, but I'm going to ask you a different thing about it. So for tests and quizzes, keep your notes so that way you can use it for the next problem if the next problem is a continuation. Because for most of the problem, they are going to be continuation. All right, any questions before I close out this meeting? Yeah, anytime. All right, so just remember for the quiz, it's gonna be open from 7 a.m. all the way to 7 p.m. But remember, once you start the quiz, pretty much there's no pausing the quiz or anything like that. Like once you press start, the timer is gonna start. It's not gonna pause for anything.
Do you know what day the first exam is going to be?
It should be somewhere next week, because we're already in chapter 3, and chapter 3 we should be done with chapter 3 somewhere probably like midweek.
And it's only going to be available from 7 a.m. to 7 p.m.
Yeah, well, it's gonna be available for a time period, but probably it's not gonna be due during the week because I do kind of want to give you some time to be able to like work on homework and stuff like that. So I don't want to do it like midweek. Once we're done with it, then you have a test on it because I know some of you might still need a little bit more time to work on homework and stuff like that. So it's probably it gonna be somewhere in the weekend, but kind of just have to figure that out.
Okay, thank
Cool. Yeah, and homework will be due the same day as the test. All right. So if you don't have any other question, you're free to go. I'll see you tomorrow. But if you do have questions, you can stay back and I'll answer any question that you might have.
Thank you. Good night, Professor.
Yeah, you're welcome, Alexandra. Have a good day.
Thank you, Professor. Have a good night.
Yeah, you too, Jennifer. Yeah, so homework will be due the same day as the test. For the exam right now, I have it scheduled for 75 minutes.
Question for the homework. The homework's the chapter review, right?
No, the homework is not the chapter review. It should be the homework at the end of the chapter.
Right. Right. So towards the end of the chapter, you get assess your understanding, and then you get chapter 1 review per se, and then chapter test. So which was the homework?
Here, let me pull up the book. That way I could just show you.
Okay.
Well, you could see if you could get like an ebook of it. Maybe Amazon's selling like the ebook of it. But yeah, you can either get like the ebook of it or you get the physical book. Let's see. Yeah, so that should be the homework where it says assess your understanding.
Okay, cool. Because since it has that and then it has chapter 1 review, I wasn't sure.
I think yeah, chapter 1 review is pretty much like at the end of the all of the chapter or all of the section in chapter 1. Then they do like a whole like review of it.
Okay, so for every chapter is going to be assess your understanding, right?
Correct.
Okay, cool. Thank you.
All right. So Stephanie, are we unlocked this? So you should be able to see chapter 4, 5, and 6 already. So if you go to Canvas right now, it should show chapter 4, chapter 5, and chapter 6 notes if you just go to whichever week I posted them on. Yeah, you're welcome. Cool. All right, you too.